Good evening. I'm PJ O'Neill, serving as Branch Chief STEM Training in the Student Programs Directorate. Welcome to this month's Tech Talk, an update on electronic marine charts and how to download them. Tech Talks are sponsored by the U.S. Coast Guard, the Coast Guard Auxiliary, and the Boy Scouts of America Sea Scout program. Tech Talks are held on the fourth Tuesday of the month at 2100 hours Eastern. Our October Tech Talk will be presented by our own shipmate, Hiram Escavi, submarine telecommunications, and power cables. Just a reminder that this Tech Talk is being recorded and will be posted on both the Sea Scout and Aux Scout YouTube channels. Please subscribe to the YouTube channels and share with your shipmates that could not join us tonight. The recorded Tech Talks make excellent training materials for your Sea Scout ship or auxiliary flotilla. So again, please like and subscribe to either YouTube channel so that you and your shipmates don't miss out on the excellent on-demand training. If you have questions during the Tech Talk, please type them in the Q&A box at the bottom of your Zoom screen, and we'll get to the questions at the end of the presentation. Now I'd like to pass it over to Hiram to introduce tonight's subject matter expert.
Thank you, PJ. It's an honor for me to present tonight's guest speaker, Miss Christie Ence. She's a branch chief in the Marine Charts Division here in NOAA. Take it away, Christie.
Thanks, Hiram, PJ. Good evening, everyone. My name is Christie Ence. I am chief of the Marine Chart Division Chart Standards Group. And what we do is we are responsible for documenting and updating NOAA paper and electronic chart specifications and requirements. So I'm going to go to the next slide. So a little bit of background. I am a cartographer, and I have worked at NOAA for 22 years. I started in one of the Marine Chart Division's production branches as a cartographer. And after 20 years of experience, I was promoted to this role. In addition to being the Chief of Chart Standards, I am also the NOAA Custom Chart Product Manager. So I am responsible for updating and developing the NOAA Custom Chart. So next slide. So I mentioned that I am Chief of Chart Standards, and NOAA aligns with international charting standards that are published by the International Hydrographic Organization. This is an intergovernmental organization that manages paper chart, electronic chart, and the new S101 data schema specifications for international hydrographic offices. So, the next slide. So, in addition to the IHO, NOAA has our own special, not special, but more developed charting standards. We base all of our standards on international specifications, and then we develop those for the best use of NOAA cartographers. So there are 3 volumes of the Nautical Chart Manual, which is basically the Marine Chart Division Cartographer's Bible. It has all of the information they need to apply their source data to the nautical charts. So let me give a brief update or summary of each volume. We have the volume 1, which was initially the very first part of the Nautical Chart Manual. It was originally written in 1920. So it is over 100 years old. It started out to be a 34-page pamphlet, and it has grown to more than 3,000 pages for all 3 volumes. Volume 1 primarily covers the rules for charting, when to chart something, who the authority is, what can you do with the charted feature according to what authority provided the information. So it's very important. It's the foundation of what we use to make and update our nautical charts. Volume 2 came along a little bit after, and that includes a lot of the specifications, not the rules for charting, but the actual hard measurements of the symbols, the type sizes, colors, that kind of thing. Volume 3, that came around only around 2000. That's a fairly new part. It looks a little bit different if you look. And that captures the ENC encoding rules. Give you a little preview. Volume 1, I'm not going to go into everything, but this is what they look like. This is an example of how to chart radio stations on our charts. So typically we only chart AM stations, and Volume 1 will tell you who can provide the information, how to assign the symbol and the label styles. Volume 2 provides the actual label styles for everything. It's basically multiple pages of text specifications, symbol specifications, and engineering diagrams for the symbols. Volume 3 goes into the actual encoding of the feature. So radio station will be RDO STA, which is a radio station in S57, which is used to depict the data on an ENC. So next, and speaking of ENC symbology, so this document that I have here, I actually made a video and I just scrolled through the pages to show you all of the symbols. I just thought it was really kind of neat. But this is the international IHO publication S52, and this shows every single symbol that you will find on an ENC. I'm not going to go into the details, but you can see that each page has information that is relevant to the symbol itself and the greater schema of the S57 chart. So. And here's the S57 chart. So this area is southern Maryland on the eastern shore. And you can see I chose this area not because I'm familiar with it, but I chose it because it had a variety of chart symbols. We're not going to go through all of them, don't worry. But this is what the ECDIS will display when you are in daytime mode and you have your safety contour set to, I believe, 1 meter. It's very shallow here. So you can see here you have buoys. This is a lighted buoy. So this is actually a 2 different features stacked on top of each other to create the symbol. So you have your buoy, which is a symbol, and a lights, which is a symbol. You have line features, LC, which is line construction. And this line construction is for a military practice area. That's River and that surrounds Bloodsworth Island. And then area patterns. This is a marsh. There's marshes in this area. And so the ENC depicts marsh areas as a line pattern with a marsh symbol. So those are the symbols, but there have to be rules behind the programming to tell the computer when to draw a particular symbol. So this is a very small snippet of the lookup table that is used. So this is a paper chart points lookup table. There are 5 different lookup tables in S57 or in S52. And this shows the full detail symbol as opposed to the simplified symbol, which you can, the users can choose which one that you prefer to see. Keep in mind, this is a text file, and this text file just has rows and rows and rows of these line instructions, these symbol instructions. So you have to keep in mind that S57 was developed in the late 1990s. So this was revolutionary at the time to allow the computer to be able to draw the symbology, even though now we consider it fairly crude. And just for an example here, we have a lateral buoy that I bolded out here. This is the symbol instruction. You can see there's a table on the bottom. I won't cover everything, but what is important is to draw the symbol, the computer needs to know that the feature is a lateral buoy, so it's buoy lat, and it has a buoy shape of 1, which is, in this particular case, a conical buoy. So continuing on, there is a text instruction as well, which is the TE, and it's taking the object name, which is the object name of the feature. So it's placing that. There's instructions on placement, there's instructions on color, and a hierarchy of the placement of the label. S52 has a level of hierarchy for symbols and labels. And if there is an overprint, the drawing order number will tell the computer which label to keep and which one to remove. There are other rules here, including your drawing display category, which is standard for this. And if you recall from previous lectures, I'm fairly certain they've talked about the base, the standard, and the other displays, where you can control the level of, or not the level of, but the number of features that are displayed, or the kinds of features that are displayed on your ENC. I wanted to compare the paper chart lookup table to the simplified points. So the simplified points lookup table has this for the lateral buoy, and you can see the simplified version is much different than the traditional paper chart or the full symbolized ENC symbol. You can see there's a little bit of a difference in the rule, and that's simply because of the simplicity of the symbol. They needed to draw out more detail. So instead of just color being 3, it has to be color equals 343, which is standard encoding for a buoy in the Ayala B region. So we have the ENC once again. I bring that up. We have a third display type of way of displaying our symbology now, and that's in the NOAA custom chart. So The NOAA custom chart does a similar thing that S52 and the ECDIS display settings does. What it does is it applies S57 encoding, and it applies a paper chart symbol instead of the S52 ECDIS symbol. And you can see, I don't know if I can go back or not, but you can see some ENC symbols become your familiar paper chart symbols. We are, I would say, about 50% done with converting the symbology to paper chart symbology. Initially, NOAA custom chart showed only S52 symbology. It originally started out looking just like an ENC. And we're slowly working through the symbology and labels to make the output look more like a paper chart. I showed you the S52 rules. Here are the NOAA custom chart custom symbology rules. A NOAA custom chart uses a combination of an XML file and Lua. And what the XML does is it organizes the Lua script into modules. And the modules are organized by the types of features they're symbolizing. So, for example, we're staying with the theme on the red buoy. And there's an else if statement saying that if the color of the buoy is 3, then it will receive the NOAA red buoy symbol. And then additionally, there is a label format that you can program that will generate the NOAA buoy symbol. So to understand what you're looking at, there is the US chart number 1, which is essentially the legend for NOAA paper and electronic charts. And you have here, I have the URL on the bottom, and I also have a QR code if you wish to scan it here on the bottom right-hand corner. Just to cover the US chart number 1 and how it's used. On every page, you will have 7 columns, or actually 8 columns, where it provides the INT symbol, which is the international symbol. You have the NOAA symbol, the National Geospatial Intelligence Agency symbol, other NGA symbols, and the ECDIS symbol. And that's unique for the NOAA's version of US chart number 1, where NOAA includes the ECDIS symbol as well as the paper chart symbol. So typically when you're looking for a symbol for a paper chart or an electronic chart, well, you're going to start in the NOAA column, and then you have the ECDIS column at the end. However, you notice there are some rows that are blank, and that means that NOAA, oops, wrong button. NOAA uses the INT symbol. So that's why the symbol is blank, because we copy what INT has. So NOAA Custom Chart 3.0. In mid-July, we released NOAA Custom Chart version 3.0. And there were 2 major improvements to the application. One was the ability to place custom compass roses to the output charts. And the second is the ability to check your custom charts against an updates website that will allow you to know when you need to update the NOAA custom chart. So 2 very big enhancements. I have a QR code in the lower right-hand side if you want to follow along. but then I'm going to move on to a demonstration. So I'm going to escape from my presentation. This is the NOAA custom chart. So this is the NOAA custom chart. You can get to it by Google searching NOAA custom chart. It is one of the first hits that you will find. You can also get to it through the Office of Coast Survey website. It has a link straight to the application as well. So this is the start screen. Some changes that we have made in the 3.0 is we have added 2 additional videos. Well, we have updated one video and added a new video with transcript to follow along. We have updated the user guide and the quick start guide for the new functionality. We have also added the feedback tab, which used to be all the way over to the right on the top panel. And we have moved the what's new to its own sub panel. So it's not taking up too much space. So if you're interested with what happened, what's new in version 3.0, you can look at that. Have the layer settings, which have not changed, other than the removal of the compass roses and the honor Skaman toggles. They were not useful at this point, so we removed them. This layer settings panel will allow you to manage what you see on the web map. So what that does is you can turn on your data extents, which are these red boxes, and these are your ENC MBRs. And I say MBR because it is the minimum bounding rectangle. Most of the time, the MBR is the same as the chart footprint. But there are some special cases when you have skewed ENCs, or sometimes very complicated ENCs that there might be multiple parts and the MVR will basically take the lower left and the upper right hand corners of that chart and make it a rectangle. So you can see here, I'm trying to find an example, but we've been slowly rescheming our charts to a gridded tiled scheme, and we may not be able to find an example, but chances are this 1 to 80,000 is a small cross chart, and those are usually the ones that give us the problems. So what we'll do, I'm doing this live. I'm going to navigate to where I was showing you the symbology. So this is Tangier Sound. This is where I was looking at, I believe. And if you can't find the place, you can always type it in. No, search. That's not it. I'm going to just choose an example. Okay, so we're going to zoom in here. Okay, so we have the Choptank River. We know that the data, I'm trying to find a good zoom here, is 1 to 40,000, right? So this cell is 1 to 40,000. I'm trying to find a good example here. That's a better. There's a 1 to 40,000. Okay, so the Timmins Island area. Okay. So is there anything larger scale? No. All right. All right. We'll go with that. So if I really wanted to, I could also have adjusted, if I knew a particular cell, an ENC cell name, I could have searched through my chart, or chart and scale. You can have both. The reason why we have it defaulted to scale is because that's primarily what you're interested in. You want to know what the scale of the underlying compiled data is, because you want to create your NOAA custom chart to be as close as possible to that compilation scale. In addition, if you want to filter data, you can turn different data sets, these intended uses. ENCs come in 6 scale bands or 6 intended uses, or usage bands. There's lots of different terms for this. And the berthing charts are the largest scale. Harbor scale charts are usually in the 10 to 40,000 scale range. Approach gets into smaller scale, 80,000. This is 40,000 here. Coastal, yet again, smaller scale. General has a very, very large coverage. It's a very large area. And then overview, we're talking about 10 million scale. So we have approach scale. I'm just going to turn all data sets on. One thing that you want to keep in mind when you create a NOAA custom chart, this checkbox also controls what the application exports. So if you accidentally have a checkbox checked that doesn't really have data, you're going to get an empty chart. So we'll leave it at all data sets, because then it will allow the programming to decide the best scale charts for you in that area in relation to your intended scale. So moving on, this is where you create your chart. It's called chart settings. First thing that you really want to do is you really want to name your chart. So I tend to look at the waterway names and I name them for those. So we have Broad Creek right here. So I'm going to name that. Okay. And I know the scale is 40,000. We have multiple paper sizes here. For 3.0, we have added a 42 by 60 inch sheet for 42 inch size plotters. But most of the time you will be using smaller page size. I'm going to go with an ANZE. You have the ability to change the orientation. Portrait is taller than it is wide. Landscape is wider than it is tall. So in this particular case, Broad Creek lends itself to be a portrait size orientation. You can control your units. So you have meters, feet, or fathoms. And the reason why we say fathoms is feet is because heights are depicted in feet. So we can go back to feet. Depth zones. You have, this is something that we have adopted from the ECDIS display. Paper charts, of course, we did not have control over what depths the blue tint went to. But for the ECDIS, we do. And we have included that in here. I'm not going to change anything. There's a 4 and a 2. 2 will make everything deeper than your safety contour white, and then everything shoaler than your safety contour blue, the darkest shoal blue. And then if you have 4 depth zones, you can set your values. The defaults are what you would see on a typical NOAA paper chart. So 5, 11, 17, it's because when ENCs are exported, they are truncated. The data is always truncated to the first decimal point. And it does not provide us enough accuracy to precision to give us the full 6 feet, 12 feet, and 18 feet. So that is the history behind that. You create a new chart, and I'm hoping that this ANSI E size is an appropriate size. Give it one moment to calculate. It is really big, so. So let's say this is actually not Broad Creek, but this is actually, what is this? Trying to pick out the island name, but I don't see it. But that's okay. We can go with this. So in addition, NOAA Custom Chart has added the ability to add custom compass roses. So one thing we will do, we will add. So select the active chart. So we only have one. And then add compass roses. Now, typically, you want to place your compass roses on land if possible, or in very deep water. Typically, you don't want to put your compass roses anywhere where you really need to see the detail for navigation. So I'm going to pick a spot here. I'm going to go over here. There, there's a buoy there, but if you don't like the position, you can always move. So you can say, okay, there's land here. You can move it there. In fact, this one I might move a little bit over to. There you go. And then I'm going to pick one more. So we don't plan on going out here. We plan on staying in Eastern Bay. So let's, now this is going to get cut off. Now we know that's going to cut off, so we're going to have to move this in a little bit. This circle, just for your information, is the diameter of the outer circle, mostly. There, I believe the numbers still stick out the outside of the diameter, and the North Star does stick out to the top. So be wary of that. You don't want to put your compass rose all the way next to the top, the top of the chart, unless if you don't care if the star gets cut off. Now, you can see I have 3 compass roses. I want to add another, right? I can't. It won't let me, because the application will only let you add 3. Since we are storing these compass rose positions in the personal chart catalog, we don't want to store unnecessary data. And we decided 3 was a relatively reasonable amount of roses for a chart. So then we can export. Now what I can do is, if I really did think that I needed to change this name, I could go back and change this name. So I could say, this is Southern Eastern Bay. And Choptank River. Oops. and then I can export it. This will take a minute. So in addition to this, I want to save this chart. So I've added it to my personal chart catalog. You can see the name, the scale, and all of the metadata for the chart is saved, including the positions of the compass roses. So next time I add this chart to the NOAA Custom Chart Maker, I can also have the same compass roses that I generated. Once you have your file, you can save. You can always call it whatever you want. So I can say Eastern Chesapeake. That's it. Now, there's this new button once my downloads drop down goes away called Check for Updates. Now, this link will take you to the NOAA navigation website, which I already have open. And this is a fairly recently released site that was actually released in conjunction with NCC 3.0. One thing that you want to make sure you read is this notice. This application provides live updates to our chart products. As soon as our cartographers add a buoy or add a critical correction to the database, it shows up here. It takes a little longer to get the chart published, and we are working on trying to determine how to filter the data so only published information is shown on the site, or have a certain filter that will allow you to filter it. But for right now, be very careful about assuming something is an update and have it released to the public. So you can see these are the updates for the last 2 weeks. And you have the ability, if I can remember which panel it opens, there's an advanced search where you can open your chart catalog viewer, your personal chart catalog. It looks just like the chart catalog viewer dialog that's a NOAA custom chart. We're going to open an existing chart catalog. We're not going to open the one that I just created because it's brand new and will not have any updates. So what I'm going to do is I'm going to open something that I created 2 weeks ago. So we already know that there's 2 charts that have available updates, but let's check them and search for updates. And what it will do is it'll overprint, and they still don't have any updates. That's interesting. What this will do is it'll check the custom chart footprint against this updates data set. And if there are any updates, it will let you know by saying that there are available updates. So then at that point, you would save your updated chart catalog. And I'm going to just call this, go back to where I was. And then I'll say my catalog 2. Save. Okay, go back to NOAA Custom Chart. Take a look at our chart that I just generated. Really quick. And there's our output. And I won't spend too much time looking at this, but you can see we have a pretty decent looking chart. Some areas where there's a lot of clutter. Here are our compass roses. I can see if I can zoom in a little bit more. You can see it has a variation of 11 degrees, 5 minutes. And there is no annual change in this area. In addition, I'm going to scroll down the next page really quickly. Oh my. It's taking a long time. Here, do it that way. Here's our ZOC diagram, which tells us the bathymetric survey quality of the area. So you can see here there is a diagram. This dark blue is A1, which is the best quality. And then as you get into the Bs, it turns into a more greenish blue. So it's B class, and then the fainter the color at that point, the less reliable the survey. Then you have your notes. I won't go through all of them, but here's your basic general notes that you will see on all charts. And then you will see more localized notes. So getting back to custom chart updates, what I'm going to do is open this new catalog, my chart catalog 2. And here's our charts. We have 2 of these charts did not have updates. 2 of these charts have. There's a new button called Select Updated, so only the updated charts are selected, and then add them to your queue to print. And it's easy as that. So that's the basic process for printing and updating NOAA custom charts. This is your paper chart solution for if you need one. In addition, if you are interested in electronic charts, I'm trying to find it. There is the NOAA. It's weird. The NOAA Interactive Catalog, which is how you would access ENCs and any remaining paper raster charts available. So we have electronic charts, we have paper charts, which ones are left. If the chart is in last edition, it will be grayed out. At this point, all of our charts are in last edition. The last chart will be canceled December 4th, 2024. In addition, you can access the Coast Pilot as well. Electronic charts, you can simply click on your area and identify the chart. So in this particular case, this is one of the rescape cells, and you can download the ENC by clicking the ENC link. If you're interested in seeing all of the ENCs in a list format, I don't know if you saw that, there is a NOAA ENCs hyperlink in the upper right-hand corner. You can actually look at the lists. They're organized by Coast Guard district, by state, and then individually at the bottom. Excuse me. So if you need ENCs, you can download them from this site. And then another thing that you might be interested in is canceled paper charts. For instance, if you need them for some reason, if you want to reminisce over old times on a particular chart that you had and you want to print it out, you have access to the historical map and chart collection, where we have archived all of the editions of our paper charts, including the very, very last edition. For example, I have here, I typed in 18748. This is one of my charts that I compiled. And you can click on a preview and take a look at the chart information. You can also download a JPEG or a PDF. It is a non-georeferenced, not georeferenced PDF. And then that takes me back to my final slide. where I provided links to the interactive catalog and to the historical map and chart collection with the QR codes. And thank you.
Okay, well, thank you, Chrissy, for walking us through the types of information that are available on the ENCs, and really interesting to see the dual outputs between ENC and the paper chart output here. For anyone, if you have any questions, you can put them in the Q&A box, and we'll relay them to Christy to see if we can get you an answer tonight. But I was thinking of a few questions related to maybe like usage and application, I guess we could say. So is there any way to like integrate ENCs with any of the GPS technology to use that, say, in a live format?
ENCs,
Like for
yes.
like real-time navigation, like ENC, not if we're downloading, we make our own custom chart and say download it and print it, but if we're just using the ENCs, I was kind of curious about that.
Yeah. Well, the ENCs, yes, because they have a geospatial aspect to them. You'd be loading your ENCs on your PPP unit or your Actis or your ECS unit. Some folks use their phone and if they need to. NOAA custom chart, the output is really intended to be a static output. It's really intended to augment your navigational awareness and not intended to be your primary source of navigation. It's simply put, the output from NOAA custom chart gives you a much broader view. It's like looking at a large format screen, whereas you have a little handheld, you only see a very, very small area that you're navigating in. It doesn't give you the broad picture. And that's really what the main intent for the NOAA custom chart is. It's also intended, worst comes to worst, it can be used for backup.
Right. But certainly a lot of, like just like the raster charts, trip planning, trying to figure out time, fuel usage ahead of time, and that sort of thing. Absolutely. So we do have a few questions that have come in. So what about inland lakes? Is NOAA responsible for charting inland lakes? Is there an organization that charts the inland lakes?
Originally, there was the Lake Survey, which was a separate organization that was responsible for mapping and charting the Great Lakes, and other inland waters such as Lake Champlain in that general region. NOAA does provide, well, let me back up there for a second. Lake Survey products were ingested by the NOAA Office of Coast Survey, Marine Division, Marine Chart Division, I believe around in the 1970s. So NOAA is now responsible for any charted lake, including the Great Lakes, Lake Champlain, Lake Tahoe, and then several lakes in the west. We don't chart every individual inland water. The Corps of Engineers is also responsible for charting the inland rivers. So they also provide inland ENCs of waterways such as the Mississippi and other major waterways as well.
So just curious, you wouldn't be able to access those charts, say for the Mississippi or one of the Great Lakes through NOAA products then, since it's a separate charting organization?
NOAA does chart Great Lakes.
Okay.
So, yes.
All right. I think that answers that one. We had a specific a question about a specific chart symbol. So I'm sure this could be a chart number 1 question.
Yeah, that's exciting.
We could refer it to, but I guess you're the cartographer here. So what is the black cross symbol on the chart? Someone must have noticed that and has a question about that particular symbol.
Oh, and of course, I'm probably going to have to look it up.
I know. That's what I was thinking.
I'm-
We probably have to refer back to chart number 1.
I am certain it is a landmark. It is probably a church. But I would
Oh,
have
on
to,
land. Right, right.
yes.
Just like radio towers and others, those kind of
Yes.
landmarks appear on navigation charts.
Yes, I'm looking at US chart number 1 right now. That is one update that we have made recently to NOAA custom chart. Landmarks originally were symbolized using the S52 symbol, which actually shows what is termed a pictorial symbol. And pictorial symbols look like the feature that they are symbolizing. So many S52 landmark symbols will look like the feature that they're charting. So a good example is like antenna and the radio antenna dishes, like the dish. It'll actually have a little dish symbol. And of course, it's not coming up. I'm fairly certain it's a church symbol.
Likely, but if you are beginning out with charts, Chris was referring to chart number 1 there. That is, and I did scan the QR code, and it does work, and so it's available very quickly. That'll have all the symbology, the breakdown of the symbols and what they stand for. While you're thinking about that, I was thinking of another question as you were presenting related to the updates. And you spoke a bit to this about how the ENCs handle, a changed environment, say like a shifting sandbar, or if there happens to be some sort of obstacle or a new wreck. NOAA gets all kinds of data inputs. So the chart updates, they're all done by humans? Are they done by cartographers and the chart isn't updated until that process happens? Or is there some sort of automatic updating also that is built into the chart, or even some type of AI, like, what types of, data inputs are updated and how for something that might change, say, like after a storm very quickly?
Right. Well, typically what we will do is we will not chart the hydrography in a very highly changeable area. That is changing. There is a new process for disseminating hydrographic surveys to our charts. It is called the National Bathymetric Source. And this data set is taking all digital data, and it is creating a surface using the most reliable, most recent hydrographic information available. And it's what they plan on doing is releasing data by request. So as a new hydrographic survey is ingested, is applied to this MBS system, we ask for the data and it's provided to us to apply to our charts. Now, there is some automation. We don't like to use the term automated cartography. We call it assisted cartography because we really don't ever want to get in the mindset that everything can be automated.
Sure.
Part of the reason why the NOAA custom, I'm used to saying NOAA custom chart, the reason why NOAA charts are navigational, are legal documents used for navigation is because a human being has verified that the data has been collected and depicted correctly. So, so there are some automated aspects, but I mean, ultimately, it's the cartographer that has to give the approval of that data before it's released to the public.
That makes a lot of sense. Looks like we have time for one more question, and this one is more a technical question on the back end here. The attendee says, "I'm studying Python programming. Now, what coding engine is being used here?"
Okay, for NOAA custom chart, it's actually using Lua programming, which is not Python, though in the past, Esri has leveraged Python programming for their custom symbology. So it is definitely something that is used. Years back before this project began, I was involved in doing the what NOAA was calling the chart template program, where we were trying to build custom templates of each chart that were linked to the ENCs, and it didn't work very well because a lot of the electronic chart encoding didn't map one-to-one to the paper chart symbology, so there was still a lot of manual work. But that entire system was well, both this and that were Esri products, and the entire engine for driving that symbology was Python scripts embedded in a larger CXML, which was a conditional XML. So the XML was the if-then statement, and then once it was a true statement, it would apply the Python script. So yes, there is a use for Python scripting. It's just not in this particular application.
All right. Well, that looks like all the questions. So I would like to thank you again very much, Christie, for taking your time to share your expertise with us. And there was a lot of information on NOAA charts and how to create our own custom charts. So hopefully people that couldn't join us tonight, whether in the Sea Scout program or Coast Guard Auxiliary, please share this recorded tech talk, because there's a lot of good information here and some sections that you may want to review as you actually are on the website or the application trying to create your own chart and play around with your local area of operation. So thanks again, Christie, and thank you all for attending tonight. We hope to see you next month for our Tech Talk on Tuesday, October 22nd, where Hiram will be presenting about submarine communications and cable. Thank you, everyone, and have a great evening.